So as we continue our study of limits and continuity, we're going to evaluate limits at infinity. So when you're evaluating your limits at infinity, and these are only applicable to rational functions, remember that your rules for horizontal asymptotes or your end behavior applies. So if the degrees are equal, then the horizontal asymptote, and thus the limit, is equal to the ratio of the leading coefficients. If the denominator has a higher degree, then the horizontal asymptote is y equals 0. And if the numerator has a higher degree, then there is no horizontal asymptote, and the limit diverges to either positive or negative infinity. So, finding the limit as x is approaching positive or negative infinity is finding the horizontal asymptote. So let's take a look at example 1. So, as x goes to infinity of 2x cubed plus 5 over 3x cubed plus 1, our powers of the numerator and the denominator are the same, and so this limit is simply 2/3. For example B, the power of the numerator is less than the power of the denominator, and so this is bottom heavy, and so this limit is 0. For C, power of the numerator is greater than the power of the denominator, and so this is going to positive infinity, and so our limit is infinity. Now, as we look at things like example 2, we need to pay special attention and think about what the resultant or the net power is. So we have the limit as x goes to negative infinity of x over the square root of x squared minus x. And so recognize that the square root of x squared is essentially x. So we can recognize then that these two powers are the same. And so as we go to negative infinity, it's going to be the ratio of the coefficients. But we need to pay attention to the fact that it's going to negative infinity. So our ratio of our coefficients is 1, but because this becomes a negative, our limit is -1. Looking at example 2, again, we have a square root of x squared, so that becomes an x. We're going to -2x. So we have our ratio of our coefficients is 1/2, but we have a negative, but we're going to positive infinity, so that becomes a -1/2. Looking at example, the next one, we have the square root of 4x squared plus x plus 2. We can ignore that x plus 2. Recognize that our net power is an x, but our coefficient is also the square root of 4, which is 2. So we have 2 over 1. Both of these are positive, and so the limit is 2. Looking at this last one, we have x cubed over the square root of 9x squared, and so the effective power is again the same. We need the square root of 9, so that's 3 and 1, but we are going to a negative number. We know we're going to have a positive in the denominator, a negative in the numerator, and so our limit is -1/3. So let's look at example 3. So we have that we're looking for our limits at infinity of each of these functions. So our limit as x approaches infinity of 2 to the x is infinity, and our limit as x approaches negative infinity of 2 to the x is going to be 0. And this is because of the shape of the function. So looking at B, we have our limit as x approaches infinity of 4 over x minus 2 squared. It's bottom heavy, so it goes to 0. The limit as x approaches negative infinity of 4 over x minus 2 squared also goes to 0. We're going to skip C and E, and those are going to be in your questions in the Edpuzzle, actually in D as well. For F, again, your limit as x approaches infinity of this, our function is bottom heavy, and so it's going to go to 0. And again, x approaches negative infinity. It's still bottom heavy, so it's going to 0 as well.